A
Sir, 31st
student.
October at town.
Yes, 31st October.
Okay, sir.
Yeah. You first read it, huh?
Yes, sir. A student is asked to find the focal length f of a lens. He uses an arrow shaped slit in a piece of card as an object as shown in figure 1.1. The object is placed at one end of a meter rule and the lens is fixed a distance u from the object as shown on figure 1.2. The slit is illuminated from behind using a lamp. The screen is then placed on the meter rule so that a sharp focused image of a arrow is formed. The distance v from the lens to the screen is then measured. Explain how student ensures that the image is sharply focused on the screen.
Yeah, how?
Uh, Increasing u like
So to
the u
they,
distance take increase করবে
you see, they are very specific in the question. How and how the student ensures the image is sharply focused on the screen. On the screen, you have to focus it, right? So you
yes sir.
you have to move the screen. It's better to move the screen other than moving the object or lens. It's better to move the screen forward and backward. But you have to do this very slowly, okay? Very carefully. Is it clear?
Yes.
So the answer should be move the screen. Yeah, forward and backward. Slowly, huh?
স্যার এটা সেট নাম্বার কত?
This is set one. Set one already you did. We are done with all the sets. So they have left you see LT and IFALS. Done. IFALS. Karim.
Yes sir.
Okay, then we are going to next part. Yeah. So this one you have to take the printout and get the reading. Have you taken the printout? First,
Yes sir.
yeah. Then check what is the value of U came.
From object to lens, it is 6 centimeter.
Object to lens, it is 6.
U, yeah, U distance.
Yeah, exactly 6.
Yes, sir.
Then from lens to screen,
4.3.
4.3. Okay.
Yes,
6, 4.3. Then the last part. Yeah, F. What is the value of F, Kim?
2.5.
2.5.
Yes,
Okay, let me check your working is correct or not. 6,
four point three.
then 2.5, right?
Yes, sir.
So ilte
Yes,
abir.
sir.
uh, this one you got printed, ilte.
I have now.
Yeah. So you can write it. Huh? The question number 1A. Move the screen forward and backward slowly. Huh?
Okay, sir.
Then here you got the measurements already. If was calculated, U is 6, V is 4.3, and F is 2.5. Then suggest one way the student ensures that his value for F is accurate. So how will get this one is accurate? How to get it?
He
Charge
repeats the
it.
experiment and takes an average.
Yes. Take several readings and get the average. Several readings of U, V, and then take the average. Right?
Does it need to be mentioned like the measurements
No.
only?
Just to mention that take several readings and take the average. Yes. Yeah, Abir joined with us. Abir, yeah, Tamjid, He's not there. Yeah, he already talked to us. It is repeated, huh, Abir? Set one is repeated here now. Hmm.
Yes, sir.
You can stay here, no problem. Just we are informing you. Already you are done with set one.
Yes, sir.
Okay. So tomorrow, Abir, tomorrow morning we will upload mock paper, huh? Mock one on this. Okay, P4, and you have to submit it by Sunday so that we can, uh, take it and discuss with you on Monday. Is it clear?
Yes,
Hello.
sir.
If you submit me earlier, then I can check. So here we go. It is two, huh? Question number two. Yeah, Karim.
Yes, sir, I'm back.
Yeah, yeah. Please read it. Question number two.
Yes, sir. The student carries out an experiment to find the mass of a meter rule. She uses a number of identical metal rings and a pivot. Each ring has a mass of 3.3 gram. Apparatus is set up as shown in figure 2.1. The student places a pivot under the 45 centimeter mark on the meter rule. She then places rings one at a time on the meter rule at point 0.5 centimeter along the rule. She adjusted the number of rings until the rule is close to balance as possible. She record the number of n rings needed to balance the rule. The, the ring are circular with a center hole as shown in figure 2.2. Measure the outer diameter of the ring.
Yeah, you have to use the ruler to get it. So you calculate it, huh? You measure it.
Just a minute, sir.
Yeah. Ifas and LT, you can have it, right? Outer diameter of the ring. What is the outer diameter?
One.
One. Are sure it is one?
Wait,
What
sir.
about Ifas? You got also one outer diameter.
Sir, I'm still checking it.
This is inner diameter. Outer diameter is this one.
2.1.
Oh, 2.1. Then it's all right. 2.1. You take also Ifas.
Sir, outer diameter is like
This is internal.
both the.
This is internal,
uh,
and
uh,
this one is outer diameter.
oh, yeah, got it. Yes, sir, 2.1.
2.1. Okay, good. Then, yeah, wait. Continue.
Yes, sir.
Karim, uh,
2.3 shows a section of the meter rule. On figure 2.3, draw one ring correctly placed at 5 centimeter mark.
so how will draw it correctly? The
So what
ring
was the diameter?
diameter was 2.1.
So then we will divide it by 2, which would be 1.05.
No, 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 no. You have
1.05
to just
centimeter.
draw it here where it is 5 centimeter mark.
The center of the
That
circle
means,
just should
yeah,
be at 5 centimeter.
yeah, yeah. The center of the ring will be at 5 centimeter mark. That way you have to
So
draw
we
it.
don't need to be accurate.
Yeah, yeah, like this shape, like this shape. Okay,
Okay, sir. Sir,
this
don't
one.
we need to draw the circle in between the
Yeah,
circumference of
yeah.
the
You
ruler?
you you draw like this. I just showed you same sample.
Yes, sir. Yes.
I just showed you the internal one. You also draw the external one. Okay. Then next, yeah, continue. Karim,
Explain
continue.
why the student adds the ring carefully one at a time.
Mhm. Yeah, why he is adding the rings carefully, one at a
I
time.
think we can go scroll a bit down
Then any more ideas? It's not
to
a
get a perfect equilibrium.
yes. Then
So that rings don't slide.
Or
yes.
the ring, the center of mass doesn't change and it topples over.
Hmm. So you can write any one of them. Okay. You can see here is a mark scheme. We see to ensure that the correct number of rings is recorded, to ensure the rings are placed in correct position, to know when ruler is close to balance. So
Means perfect equilibrium.
yeah, to ensure the rings are placed in correct position, to ensure that the correct number of rings is recorded. And the last one is very close to your answer. That is to know when a ruler is close to balance.
So, sir, would I have got marks or not?
Yeah, you will. Then continue.
Yes, sir. The distance between L, the distance L between the pivot and A is changed by moving the pivot closer to A. The student repeats the experiment for different values of L, draws a table of result as shown in figure 2, in table 2.1.
Yeah. So we have a table here. We have L and N, right? N
Yes,
means
sir.
N means
Newton.
Newton or
I
number.
don't know, sir. We use, okay, sir, number.
What number? Number of
Number of rings.
rings. Yes. So number of rings are N and L centimeter. So the distance L between the pivot and point A. You see, you understand it now, right? What is L?
Yes, sir.
Yeah, and here is number of rings. So this L and number of rings are varied, and we are getting a table like this. Okay, so what we have to do? We have to draw,
Plotted on the
yeah,
graph.
y-axis. Y-axis you have to give n, and x-axis you have to give L. Draw the base fit curve. You have not printed, right? This one?
No, sir, but I have a graphic.
Yeah, you will get it and you can draw it, no problem. We get the idea from others. Yeah, Ifaz,
Yes,
Ifaz,
sir.
have you got the graph? Did you draw the graph?
No, sir.
Not yet, right? You are
Not
drawing
yet, sir.
now. Yeah,
Yes, sir, I'm drawing.
yeah, draw it now, no problem. Then Ilti, have you drawn?
No, sir, I'm not that fast.
Yeah, you draw it. You already became very expert in drawing, right? So you start from 0, 0. You have here L till 40, so that means eight. How many big squares are there? You check. Normally there are eight. Check here. One, two, three, four, five, six, seven, eight. So from 0 to 40, you can take 5 each, right? 5, 10, this
Yes,
way
sir.
you go 40. And for n, you got
10
from
per box.
0 to 70. So you can take it from 10, 10, right? For each big square, you take 10, 10. Then you draw best
Yes.
fit curve line, send it to our messenger group, then we'll see it, huh? How it is working as best fit curve line. Karim can also see, huh?
Yes, sir.
Do it, please. So, Karim,
Yes,
this will
sir.
be very good practice for you today, right?
Yes, sir.
Then you can comfortably do the mock, inshallah. Okay.
Yes, sir.
So we have some more questions here. By this time, you can try them. Like question number 3, question number 4. You go through, huh, Karim? By this time,
Yes, sir.
yeah.
Sir, I'm done with the graph.
Who?
Sir, me.
You are done, mashallah. Then can you send the screenshot?
Yes, sir. I would just take 2 minutes.
Do it. Do it in the group. Huh? You send it in the group here. Yeah. Did you give the quantity and unit, Dilti?
Yes, sir.
Here I see n is given, and here you give L centimeter, right?
sir.
Okay. 0, 10. So from here you jump. This one is 10 or 20. This is 20, right? This is
20.
10.
Yes, sir. 10.
Okay, then all right. 0, 5, 10, 15. Okay. Okay, then done. Then you do the rest part next time. You have here N18. You find N18 where L equals 18. Corresponding to L18, you find N. This is L18 here. This is L18 here. So you go here and check what is the reading coming for N.
61.
Hmm?
61.
51.
61.
61. Okay, write 61 then. No problem. Yeah. Yeah. Do the graph more continuous, eh? Like here ups down. There should not be up down. Okay. Continuous curve. Like here little bit
Yes, sir.
down. So here you got an N, right? Did you show N?
Yes, sir.
Where?
Yes, sir. On the top.
The top. Okay. Fine. Then you find now for 18. 18 L equals 18. You find N. Okay.
Yes, sir.
Sir, you should have got it now.
Hmm?
Sir, I have sent it.
You also sent where? Now.
Sir, in the group.
Okay. Okay. I'm checking it in the group. Now. It's yours.
Yes, sir.
So which one is 0, 10? So 20, 30, 40, 50, 60, 70. Huh? 70. Yeah. Yeah. Get it now. Yeah. Okay. It's all right. Now you get for L18, get
It's
N.
29.
It's 29.
Yes, sir.
For L18, you go
Yes,
up,
sir.
get
Oh,
number.
L18.
Yes.
Oh, I took it N18.
No, no. L18. L18. Yeah. If as what you got for L18, like for L equals 18 centimeter, N18, what you got?
51.
You got 51.
Yes, sir.
And LT got?
61, sir.
You got 61. How come so difference? Big difference? It should not be that much different.
Sir, I got 48.
48 and 51 is close, but 61 is very far. It is check. It is 16,
No,
17,
sir, it is just a
18.
difference of 10.
You see, 18, where it will go? 6 small square, right? After 15, 6 small square. There you go. Check again, LT. Maybe you took 3 small square after 15. LT, are you checking? Hello?
think I did a mistake. Yes.
Yeah. So that should be 6 small square, right? After 15. So now check what is your reading. Hmm? Check.
Sir, a change in decision. It's
52.
52.
Your one is 52.
Yes, sir. I mistakenly took 19. Now
Oh,
it's okay. Six more squares.
okay.
Since
So
52.
you got 52. So you see the range is from 50 to 53. So if as one is here in the range, then 52 you got 52 that is in the range also inside the range.
It's 52.5 actually.
Yeah, whatever. If
So
you
what do I write? 52.5 or
you write 52 or 53, you check
okay,
where it is exactly. There you get. Okay. Then calculate it, huh? Calculate mass of the meter roll. And you have to write the answer in two significant figures. Whatever you are getting in answer, you have to make it two significant figures.
sir, what do we use in L?
Hmm?
What
Yeah,
do we use in L?
L is 18.
Ah, okay,
L,
sir.
L is 18 here. N18 already you got here. Whatever the value you got here, that one you'll write N18 from the graph. Then 45 minus L. Take. Done.
Yes, sir.
So what you got? M.
1112.120.0.
So 111 1
116.6 it was.
116.6.
Yes, sir. So
So
it would be
one,
120.0.
yeah, 120. You can write 120. That's it. Okay, two significant figures. So the answer is here 114, then 110 in two significant figures. And whatever you got in your reading, you write that one. You got 116 point something, right? Then you write
Yes, sir.
116. That one you write. You show your working. For that one mark. And to write in two significant figures, there is another mark. Okay, whatever you get, no problem. And if even if your this answer is not in the range, then you'll get marks for your correct calculation and writing in two significant figures. That is error carried forward. Huh? You will get the marks, no problem. If your calculation is correct and writing in two significant figures, and you, uh, Ultimas, what you got?
110.
110 you got. Then Syed Ifaz, what you got?
Yes, sir. Same. 110.
You got 110. Then Karim, you got 120, right?
Yes, sir.
Okay. You check your calculation again, no problem. We will go through again, no problem. Now you see 4. Continue 4, Karim. Name a piece.
Oh, sir.
Hmm.
Sir, it comes 114 only if we use 52 or 50 or 51. So on that time, it's on the range.
Yeah, yeah.
But I used 53 means the
No
maximum part of
problem.
the range. So
If you use 53 and it comes 120, no problem. It will it will work. Okay. But you do accurately. Whatever you are doing, you do accurately in your graph or everywhere. Working also. So
yes, sir.
4. You read 4.
Name a piece of apparatus that can be used to check whether the theory is correct.
Yeah. Which apparatus will use now? Like the value you got, you can verify it using an apparatus. Which apparatus you use?
Sir, measuring.
You
No, not
balance,
measuring.
balance, top pen
Yes, sir,
Balance.
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 Sir, it was not in my
Electronics.
Yeah,
mind.
top pen balance we can use. Then C, read C.
Digital balance meter.
Yeah, okay. Any balance, you can write balance only. That is also correct. Yeah, C.
Yes, sir. So just one way in which this method of measuring the mass m of the meter rule can be improved.
Yeah. How can we improve it?
Uh, by using the ring of much lower mass.
Yes, yes. Very good. By using the rings of lower mass. Then any other idea? Any other idea?
Large